Hello everyone, welcome to our presentation. Today we are going to talk about our paper benchmarking and selecting optimal diabetic retinopathy detecting machine learning model using entropy and TOPSIS method. The paper will be presented by me, Shoili Roy, and my friend Sajjad Ahmed. So, what is diabetic retinopathy? The light sensitive layer of retinal cells converts light into electrical signals, which are then sent to the brain where they are turned into the images we see. A brilliant network of teeny blood vessels constantly supplies blood to the retina. Hyperglycemia, a condition where glucose levels in the blood are high, can affect every part of the body, including the precious eyes. Diabetic retinopathy is caused by hyperglycemia or high blood sugar levels. In this condition, blood vessels of the retina are damaged and they swell or leak the blood. According to a statistical analysis, 90% patients will be reduced if the patients get good treatment and be under good monitoring, for which the disease should be detected in an early age. There are multiple neural network models and machine learning models to detect DR optimally from a given dataset. However, selecting and using the right optimal ML DR detection model that provides reliable and accurate DR detection result is a bit challenging. Thus, benchmarking and selecting the optimal method from all the options is an important matter of concern. In our study, the primary goals of our research works are proposing the intelligent methodology to play an important role in medical science. The study intends to propose the methodology for helping the health organization in the selection of diabetic retinopathy detection model. Then, for the benchmarking and ranking purpose, this research plans to implement an integrated multi-criteria decision-making method where TOPSIS can be applied. For calculating the weights of criteria, the study aims to use entropy. In the previous work, a hybrid machine learning model is proposed that combines a custom Inception V3 for feature extraction. This paper applies the mentioned model along with other models in a public set of eye fundus image for extracting the feature and compare the performance. After that, our research aspires to incorporate machine learning models with TOPSIS method for evaluating the final result. Most importantly, the main goal is to recommend an effective detection model of diabetic retinopathy. There are several researches on diabetic retinopathy detection. If a patient has diabetes for more than 10 years, he or she has a higher probability of having retinopathy disease. Doshi et al. Have proposed a deep convolutional neural network approach to detect diabetic retinopathy that learns features which are vital in the detection of the disease instead of direct or explicit extraction of the features. The authors have pre-processed the dataset with a scaled resolution using a control line tool for image processing, ImageMagick, and OpenCV for Python library. To speed up the training, activation function leaky rectifier is used in the neural network model. For analyzing the result, the researcher has prepared quadric weighted kappa metric using the previously calculated grading values. Roy Choudhury et al. Have tried a screening system which is computer aided. In short, it's called DREAM, that inspects insolent images with different radians and areas of view and produces grades for diabetic retinopathy on the basis of machine learning algorithms like SVM and KNN classifier. For grading the feature automatically, the authors have performed three-stage algorithm. In the first stage, regions corresponding to the optic disc and vasculation is detected as the image background, applying an algorithm called minimus, which means minimum intensity, maximum solidarity. In the second stage, the authors have invoked classifier to classify the regions with binary value. Lastly, a combination function is proposed to combine the count of red and bright lesions. Then the result of the three stages algorithm is evaluated, calculating sensitivity, specificity, and ROC curve. Similarly, Abraham of ETL have suggested automated retinal image detection using calculation of sensitivity and specificity. The authors have collected the dataset capturing the eyes images of 874 people and graded it manually with several experts. Basically, the motive is to evaluate Iowa Detection Program IDP towards detecting diabetic retinopathy, which outputs DIR index with grade 0 to 1 and identify the patients who should be referred. In addition, TOPSIS and machine learning models are implemented in other aspects of disease detection. Mohammed ETL have applied several machine learning algorithms to predict presence of COVID-19 and then benchmark the model based on TOPSIS method. Initially, the authors have applied several machine learning algorithms after pre-processing the dataset like support vector machine, random forest, decision tree, k nearest neighbor, logistic regression, gradient descent, etc. Then F1 score, ROC, false positive negative value, true positive negative value are calculated to find out the method that activates the best result. Now, based on the calculation, the authors have prepared a decision matrix to integrate entropy and topsis in the paper. Support vector machine has performed in the best according to the TOPSIS method. Nevertheless, the research that we have proposed is inspired by the work of Santiago Toledo Cortes and the team. The authors have worked on decision of diabetic retinopathy detection, extracting the features from the dataset using Inception V3 and then applied hybrid deep learning Gaussian process which combines deep learning and generalization of dataset using Gaussian process. Here are the reference that I have talked about till now.
Now I am going to discuss the dataset. In this experiment, we have used two different datasets. The first one is the IPEX dataset, which is collected from the Kaggle, and it comes with 5 different grades of DR condition. And as you can see, these grades are actually graded by clinicians. Even though there are 5 grades, we can still form a binary classification task by defining the grade 0 as no DR condition and the rest 2, 3, and 4 grades as the DR condition. After fetching these images, we perform the pre-processing pipeline, which includes different transformation, and then we also apply the Inception V3 model to extract the features. After the feature extraction, we keep this dataset for training purpose. And then the next dataset that we have used called MISIDO2 dataset. It is often used as a standard dataset to compare performance result of DR diagnosis tasks. In this dataset, there are not that much samples compared to the IPEX dataset. And for this dataset, we perform the similar pre-processing pipeline and also the feature extraction method similar to as IPEX as well. And we keep this dataset for the validation purpose.
Now we're going to talk about our method overview. You can already see that our method has three parts. One is model development, another is model evaluation, and other is benchmarking. In the model development part, we generally worked on dataset, then pre-processing and selecting the machine learning models. After that, in model evaluation part, we generated some metrics and evaluated based on those metrics. After that, in benchmarking part, we used TOPSIS method, which will be talked in detail later. So if I want to talk about our pre-processing, after fetching the dataset, the images are pre-processed using the pre-processing pipeline. The pre-processing pipeline step combines the DR grading standard. The pipeline takes account of different situations such as out of focus, darkness level, exposures, etc. This process automatically discards low quality image. Then, after filtration, it also crops darkness levels and only the region of interest is selected. Then, finally, the images are resized at 299 into 299 pixels. It's because it's hard to process data of big size and the work is getting a good accuracy with 299 into 299 pixel. Then, if we talk about the model development part, so at the first, DR datasets are preprocessed, and after that, we tried Inception V3 to extract the feature from the images. Then the study performs an array of machine learning algorithms to detect diabetic retinopathy cases. Here, the machine learning models like Gaussian naive Bayes, k-nearest neighbors, decision tree, random forest, multilayer perception, ADA boost, extreme gradient boosting, support vector machine are applied. So now, if we want to talk about model evaluation, the model's performance is evaluated against certain metrics like area under curve, accuracy, precision, recall score, F1 score, true negative rate, false negative rate. However, TP, TN, FP, FN, etc. are omitted from the final evaluation criteria list because these are count values and these may vary based on the size of the dataset. After that, in case of benchmarking, we used TOPSIS method, which is the main focus of our research. So the TOPSIS method has basically two parts, entropy calculation and then the TOPSIS calculation. In entropy method, entropy basically differentiates the existent contrast between a set of data and analyzes the rank of the information to make decision. Entropy measurement is done in the following stage. In the first place, a decision matrix D is built. The decision matrix contains the information of a particular criteria. The matrix consists of m rows and n columns. Here, n is the number of criteria and m is the alternatives of particular criteria. The entropy measures of the project outcome is calculated based on the following equation where h is the amount of data, Pij is the standardized data and Eij is the entropy information. And here K is a constant which refers 1 by ln of H. After that, weighted value WTJ is determined to define the object weights based on the concept of entropy, which reflects the importance of the metric in the evaluation system. We have already learned about EIJ and WTJ, and here A is new, which refers to the total number of attributes. TOPSIS method starts from these equations. TOPSIS is basically a multi-criteria decision analysis method. In the work, 6 steps are followed to implement this method. Firstly, the decision matrix is normalized to transform the different dimensional attribute into a non-dimensional attribute. And for computing all the attributes, Rij is the normalized value of matrix D. Xij stands for matrix data, and M is the total number of data. Secondly, the previous decision matrix D is combined with weight by multiplying a weight value Wij with a matrix value Rij that results in new value Vij and calculated new weighted normalized matrix Vm. The matrix is not shown here, but it just looks like Wij into that Rij, which equals Vij. After that, the ideal solution A plus and non-ideal solution A minus are calculated from the normalized decision matrix PM. After that, the separation matrix is determined using a previous calculation of separation from positive ideal solution is positive K and negative ideal solution is K minus. VMKG stands for this one, it stands for the matrix value of Vm positive J means the value of positive attribute J, and Vm minus means the negative attribute J. Here you can see the equation where the positive Sk is calculated. Similarly, the negative Sk is calculated based on this equation where Vmkj and Vm minus j is already explained. The step is for finding out the related closeness C star of the ideal solution. Here you can see that closeness solution. Firstly, they will use this equation to find out the value where closeness solution can be 1 if ak is equal to a positive. Otherwise, it will be 0 if ak is equal to ak a negative, and a negative a positive is already calculated earlier. Lastly, the preference order is ranked based on the descending order of the relative closeness value Ci star of the classifiers. That means which will be a range of 0 to 1.
In this experiment, we have run several classifiers in the preprocessed dataset, and the result of this classifier has been shown in this table. As we can see, in terms of the accuracy, the MLP classifier performs the highest and the SPM classifier performs the lowest. The random forest classifier achieves the highest performance in terms of the precision, false negative rate, and true negative rate. However, it also performs the lowest in terms of the F1 score, true positive rate, and false positive rate. The naive-based classifier performs highest in terms of the F1 score and true positive rate. However, it comes out with the lowest result in terms of the false negative rate, AUC, and time. The MLP classifier achieves the highest in terms of AUC, accuracy, and recall. Then we discuss the entropy method. The output of the entropy method is shown in this table too. Here good to mention that the higher entropy weight value is considered as the most important criterion. Similarly, the lower entropy weight value refers the less importance. As we can see in this table, the time criterion has achieved the highest importance based on the entropy method, and the second important criteria that we have found is the false positive rate, and respectively we can see the false negative rate. Then we perform the TOPSIS analysis, and based on the TOPSIS ranking, we can see the Adappost classifier has ranked the best performing method, or the best method to classify the DR images in terms of the based on the criterions that we have provided, and it satisfied the most criterions in the best possible way. And similarly, the second best classifier that we have found is the MLP classifier. Behind all these classifiers achieving the highest rank, we can actually think about the criterions weights that we have generated in the previous steps. And these weights can also be modified based on human preferences as well. So that's all from our end. In this experiment, we have tried to show that we can develop different sorts of classifier to classify the DR images, and based on these classifiers output, if we need to pick the best performing classifier that satisfies most of the criterions, then we can use entropy and TOPSIS combinedly to pick the best performing method. And here, as per our demonstration, we have seen that the AdaBoost classifier was the best performing among other classifiers. In this experiment, we couldn't actually include the rest of the state-of-the-art DR classifiers, but it's just for demonstration purpose only. We also tend to work further in the future as well. So thank you for attending this session. Please feel free to ask if there is any question. Thank you.